Welcome to the DIY Honda Garage channel. DTC P0365 relates to the CMP camshaft position, sensor B circuit signaling that there is no signal being detected. The camshaft position sensor is a crucial component in modern engines as it provides information to the powertrain control module, PCM, about the position of the camshaft. This information is essential for the accurate timing of the engine's ignition and fuel injection, ensuring efficient performance. In the Honda Accord, the CMP sensor B is typically located near the camshaft on the engine block, making it easily accessible for diagnostics. No signal from the sensor can lead to poor engine performance, increased emissions, and potential stalling or failure to start. Addressing this DTC promptly is vital for maintaining engine efficiency and reliability. The DTC P0365 highlights an issue with the CMP sensor B circuit, specifically noting that there is no signal being received. The CMP sensor B works by monitoring the position of the camshaft, which is essential for synchronization with the crankshaft position sensor. These two components collaborate to ensure that the engine operates smoothly and according to the designed timing. In the Honda Accord, this sensor is typically located on the engine block in close proximity to the camshaft, ensuring it can accurately monitor its position. The output of this sensor is transmitted to the PCM, which processes the information for optimal fuel and ignition timing. Any fault in this circuit can disrupt engine performance, lead to diagnostic trouble codes being triggered, and potentially cause the vehicle to enter a reduced performance mode. Several factors could contribute to the occurrence of DTC P0365, each warranting thorough investigation. Firstly, wiring issues could include frays, shorts, or breaks in the connections to the CMP sensor B. A poor connection at any point can prevent the proper transmission of signals to the PCM. Secondly, connector problems, such as corrosion or loose terminals, could hinder electrical signals, resulting in a no-signal condition. Thirdly, the CMP sensor B itself might be faulty due to internal failure or damage, necessitating replacement. It's important to consider that intermittent issues can occur, prompting a visual inspection of all wiring and connectors before confirming that the sensor is defective. Each of these potential causes should be assessed logically to determine the root of the problem effectively. When DTC P0365 is present, drivers may notice several symptoms that indicate a disruption in engine performance. One primary symptom could be engine misfires, which manifest as a loss of power, vibration, or hesitation during acceleration. Another common indication is rough idling. The vehicle may shake and feel unstable when stopped. Difficulties starting the engine may also arise, which can be particularly concerning during colder weather. Additionally, increased emissions could result from improper fuel-air mixture due to incorrect timing from the camshaft position discrepancies. All these symptoms underscore the importance of addressing DTC P0365 promptly to avoid further complications with engine efficiency and overall vehicle operation. The first step in troubleshooting DTC P0365 involves verifying the problem using the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on position without starting the engine. Once in this mode, clear any stored DTCs using the HDS tool. After clearing the codes, start the engine to see if the DTC reappears. It's essential to check for both pending and confirmed DTC statuses with the HDS. If DTC P0365 reappears, proceed to the next troubleshooting step. If it does not, there may be an intermittent issue that needs further investigation, particularly with connections or terminals at the CMP sensor B and the PCM. You're looking for issues that existed at the time of the recorded DTC, so definitively confirming its presence is key. Next, turn the vehicle to the off-lock position, ensuring all electrical systems are completely powered down. Disconnect the CMP sensor B3P connector carefully to avoid damaging the pins. With the connector removed, turn the vehicle back to the on position again to initiate the electrical system. At this point, measure the voltage between specific test points, particularly between the CMP sensor, B connectors, and body ground. This process will help you determine if there is approximately 5.0 volts present, which is the expected voltage for the CMP sensor's power supply. If the voltage reading is correct, you may proceed to the next troubleshooting phase. If the reading deviates from this expected value, further investigation into the VCC1 power line is warranted, indicating possible issues within the wiring or connections. After verifying the voltage in the previous step, it's crucial now to test the integrity of the VCC1 line, which is essential for the sensor's operation. Start by turning the vehicle to the off-lock position, and then utilize the HDS to jump the SCS service check signal line, allowing for a short circuit condition to be simulated. After waiting for more than 1 minute, disconnect the PCM connector E80P with both the CMP sensor B and PCM connectors detached. Perform a continuity test between the respective test points to ensure proper connectivity. This involves checking for continuity between the CMP sensor B connector and its corresponding terminal on the PCM. If you find continuity, the VCC1 wire is functioning correctly, and you can check for additional service information related to this DTC. However, if continuity is not observed, repairs in the VCC1 wire will be necessary, addressing potential breaks or disconnections that are causing the no signal condition. In this next step, measure the voltage again to further assess the signals sent from the CMP sensor B. With the vehicle in the on position and the CMP sensor B connector still disconnected, focus on test points assigned to the CAM-EX line. You're aiming to measure the voltage between the designated pin on the CMP sensor B connector and body ground. If you find approximately 5.0 volts present, it indicates that the CAM-EX line is operating as it should, and you would proceed to the next step. However, if the reading shows that the voltage is not as expected, that could suggest an abnormality in the signal line itself. This needed check can help narrow down whether the CMP sensor B is functioning properly and if connectivity across the various lines is intact. This step focuses on verifying the SG1 line by measuring the voltage between two specific terminals on the CMP sensor B connector. Begin with the vehicle in the on mode and the connector still disconnected. Use a multimeter to check the voltage between the two designated terminals within the CMP sensor B connector. The expectation here is that you should detect a voltage reading around 5.0 volts. If you verified that this condition is met, it indicates the SG1 line is indeed functional and not the source of the no signal issue. Subsequently, follow up with additional authorized service information or consider substituting a known good PCM to complete your assessment. However, if the voltage falls short of the expected level, further investigation into the SG1 wiring will be necessary, requiring repairs to restore proper circuit functionality. During this step, we revisit the testing of the SG1 line for any continuity issues. Ensure the vehicle is totally powered down by turning it to the off-lock mode before proceeding. Jump the SCS line once more with the HDS and allow time for the system to reset. With the connectors still disconnected, specifically check the continuity between the CMP sensor B connector and the corresponding terminal on the PCM connector E80P. If continuity is confirmed, it indicates the SG1 wire is in good condition, and you can look for any authorized service information related to the DTC or symptoms before suggesting a known good PCM. Presence of continuity reassures you that this path for signal transmission is intact. If otherwise, it highlights the need for repair in the SG1 wire between the respective components to rectify the no signal report. In this step, the focus is on checking for shorts in the CAM-EX line, which is crucial for the CMP's operational integrity. Start by turning the vehicle to the off-lock mode to ensure a safe testing environment. Similar to previous steps, utilize the HDS to jump the SCS line and wait for the system stabilization. After disconnecting the PCM connector E, ADP, you will assess the continuity between the respective test points defined earlier. If continuity is present, this suggests that the wire for CAM-EX is functioning without issues. However, if continuity is absent, it indicates a short has likely occurred somewhere within the wire, necessitating repairs to restore correct wiring and signal transmission, thus troubleshooting the DTC effectively. During this final troubleshooting phase, continuity for the CAM-EX line is reassessed, with the vehicle in the off-lock position. Check the continuity between the CMP sensor B connector and the specific terminal on the PCM connector E, ADP. This test is critical to ensure that the CAM-EX wire is intact and functioning correctly. If continuity is present, it reassures you that the signal pathway is correctly established and operational. Should continuity not be detected, this points to an open circuit within the CAM-EX wiring that will need repairs to maintain signal flow. Upon completion of this test, you should consult authorized service information once more to link any remaining concerns or further guidance to resolve the DTC effectively. Once all troubleshooting and repair steps have been completed, it is crucial to verify that repair work has resolved DTC P0365 effectively. Start this final verification process by using the HDS again to check for any stored diagnostic trouble codes. Confirm that no codes related to the CMP sensor B or circuit are present. Following this, a test drive should be conducted under various conditions to ensure that the vehicle operates normally without triggering the DTC again. Monitoring the engine performance metrics during this drive can provide additional assurance that the repairs have taken effect and that the system is now functioning as intended. If the DTC does return, this may necessitate further inspection or consideration of other underlying issues. To prevent the recurrence of issues similar to DTC P0365, implementing a solid preventive maintenance plan is essential for the health of your Honda Accord. Begin with a regular inspection of all electrical connectors, especially those linked to sensors, such as the CMP sensor B. Ensure that no corrosion, loose connections, or physical damage are present that could lead to signal interruption. Next, it is prudent to periodically check the wiring condition for signs of fraying, wear, or environmental damage, as these can often lead to unexpected failures. Moreover, consider proactively replacing old or worn-out sensors during routine service intervals, particularly if they're showing signs of deterioration. Such practices can significantly reduce the risk of future diagnostic trouble codes while enhancing overall vehicle performance. In conclusion, effectively diagnosing and resolving DTC P0365 requires a systematic approach to troubleshooting. Initially, it's essential to verify the DTC with the Honda Diagnostic System, HDS, to understand its current status. Each step should be followed meticulously, examining all wiring connections, testing for voltages, and confirming the integrity of the CMP sensor B, and its associated components. Poor connections, faulty components, or damaged wiring often lead to no-signal conditions that can disrupt engine performance, and recognizing these early can save time and resources. Finally, establishing a regime for preventive maintenance will help prolong the lifespan of engine components and maintain optimal performance. By adhering to these guidelines, you can ensure a comprehensive and effective resolution to DTC P0365. Please like and subscribe to the channel. See you next time!